Okay, so today we're going to talk about how you can drive your application development through BDD, Behavior-Driven Development. Before we start with that, I think I better present myself a little bit more. My name is Einar Ingebrigtsen. I'm a consultant running my own company called Doolittle Studios. I'm a Silverlight MVP and has been around in the business since about 1994. I started doing games development back then and has basically been in the .NET space, the line of business space, the last 10 years actually, since .NET was in beta. So a little bit more about myself. I do some open source development. I did a 3D engine for Silverlight, and you can find that on Coplex. I also do, I'm the co-author of something called Bifrost, an enterprise application development framework, and also a headless JavaScript test runner called Forsetti that you'll find on GitHub. So before we get started, there is also the opportunity to win a TypeMock isolator /isolator++ license. All you need to do is pretty much tweet something related to this webinar that you find interesting or you want to tip anyone else with, and hash it with unit testing and CC it to TypeMock. TypeMock will then choose a winner and announce it next week. So without further ado, I think I'm going to just get started. I'm going to do all the Q&A things at the end, so please hold off with questions till the end. Okay, thanks. So basically, I got into unit testing back in 1996, and this was doing games on platforms like PlayStation and Sega Saturn at the time, and also PC DOS for the most part. And I got into unit testing back then, and we didn't have much of a kind of the things that we have today, where we have like a unit test framework and you have the kind of continuous integration things that we are pretty much getting used to today. So we had to sort of, well, not even invent things. We just basically printed out things. But we had it running on a build server. So every time we ran a build, we could go in and see what our tests were doing. So our code was working or wasn't working, which was awesome. So that got me into it already back then, and been sort of back and forth on and off doing test-driven development, or for the last 4 or 5 years, more like BDD style testing, behavior-focused testing. So I kind of came up with this 9 phases of unit testing that I think a lot of people actually go through. You basically start with trying to figure out what is unit testing and kind of what kind of value would that have to me. And you might actually go into kind of this rejection mode where you find, well, I don't have time to write those tests. It's added code. It's added kind of adding complexity maybe even to your solution. You come up with all kinds of excuses to not do this. So, well, you kind of then move on to like, oh, maybe I'll give it a shot then. Well, let's see what can it bring to the table that is interesting. And you start sort of blogging about it, maybe talking about it, and sort of starting to embrace this. And all of a sudden, it kind of just falls into place, right? And you think you've just got it all. And you're starting to actually start to test everything. You're desperate for that 100% code coverage of everything. You want to test every aspect of your system, even your internals, even your private stuff in your methods, your private methods in your classes. So you're going for that. Okay, so instead of playing this, so this was my kind of unit testing that I used to do back in '96. So bringing this to sort of the the 9 phases of unit testing I was on about. And basically from that notion of trying to get to 100% code coverage, you start discovering things like mocking and quickly run into abusing it, totally abusing it, because now you can start mocking everything, and you can, it's so easy to actually test things that are actually closed down and maybe even sealed in the .NET framework. And you start mocking these things out, and you're really kind of loving it. And then you discover how to write effective tests, and that's when it kind of all really snaps into place, and you start enjoying it, and you start enjoying looking at everyone else that really doesn't do test-driven development or anything similar, and just enjoy how much less bugs you have compared to them. So why do we want to do this? Why do we want to go through those 9 phases? Well, basically what testing can do for you is to improve your quality, the quality of your code, add a certain predictability to your code, because all of a sudden you have this safety net that sits underneath it and actually will pick up the pieces if something fails. So, and it also adds what I call a changeability. So the ability for your code to actually be changed and be sort of future-proof. So you add this agility to your code base that you normally don't have. It's adding also to you, and you as a developer, this sort of reassures you that you can go in and change things and be notified if you break something. So, going into this, in TDD, one of the most important notions is actually to go in and write the tests first, instead of writing them afterwards, or retrofitting testing. You actually go in and write them first. And the reason behind this is actually to get to the API much faster. And you get a feel for the API much earlier than you would without doing that. So if you go and retrofit tests afterwards, you're pretty much stuck with the API already there. Of course, you might feel the pain at that point and actually start refactoring. So doing this ahead of time, doing it before you actually start writing the code, makes it a lot easier for you to actually get to the right API at the very beginning of the project. And also what is really important about in any form of unit testing is to have them running continuously. So you want to have them run on your build server, feedback loop. So you want to run your tests as frequently as possible, and sort of integrate your tests into production code as often as you can possibly do. And that's really, really important, so you can actually catch all of these, all the problems that you might have when changing stuff. So you want to catch things as early as possible. So that brings me over to the 10th phase, or as I like to call it, let's skip all 9 and let's talk about behaviors. So BDD was coined by Dan North back in March of 2006 in an article he wrote for Better Software magazine. And basically, this was his reaction to TDD, which was at the time very popular and is spreading around in pretty much the entire development atmosphere, all the spaces of development. So what he found problematic with TDD was not he couldn't focus on the behaviors of your system and basically get to the stuff that the users were talking about, the kind of behaviors they were talking about, how to actually get down to that level. So he wanted something that improved the dialogue with the non-developers on the team, or even the users directly using the software. And BDD actually does that. It will come to that, to the details of this, but it will improve the dialogue with non-developers because it has a certain way of you write things in a certain way, and you get to this syntax that is actually really easy to read. And it's all about modeling the behaviors of your system. So it's a mindset, right? It's a mindset your developers need to be put into. And it puts the developer closer to the actual business value you're trying to create for your end users to actually use the software. So another aspect of it is that it's also a lot easier to read specifications written with a syntax. So the BDD style is actually a lot easier to read from a developer's point of view as well. So if you're going to read code that someone else wrote, it will be a lot easier to actually go and start and look at the BDD tests and see how does that code actually work and get a good feel of how it actually works as well. And someone coming into testing, and that's why I kind of say let's skip all the other 9 steps and go directly to this, because if you're coming into testing and have not done testing before, chances are it's a lot easier for you to actually pick up on writing behavior tests than the regular, what I would call regular TDD style tests, because it's so much easier to actually understand and model behaviors in a system. As I mentioned, it focuses on the points to have in the system. And you have a very data-driven application. But from a user's point of view, the user is doing behaviors to the system, and that has a result in data. That has a consequence in data. It might have a consequence in data. It doesn't necessarily need to have a consequence in data. So that is a bit of a mindset shift if you're going into BDD. You need to actually start thinking about the behaviors instead of thinking about your data. And all good things can come from this. There is no need to think about data. Data is just a consequence of actions or behaviors done by the user. So where does this apply? Well, I would argue everywhere. So ranging from like acceptance level to a unit level, I would apply BDD to all this instead of thinking of, I'm going to do my unit tests in regular old TDD style kind of testing, and then I'm going to move over to BDD for acceptance. I think it's really important to actually get this mindset into you as a developer and do it all over the place. So apply this on all levels of your software. Because in short, your software is just a bunch of behaviors. Even at the lowest unit level, it's basically behaviors. Even if the behaviors are executed by the system, it's still a behavior of the system. So I think it's really important to actually get that throughout. So at the heart of, or at least eventually at the heart of BDD, is something that is often referred to as Gherkin. It was actually introduced in 2008 by Aslak Hellesøy, the author of Cucumber, a BDD style framework for actually running these specifications in and the language is a highly readable domain-specific language which specifies the behavior of your system in a very good way. So basically Gherkin looks like this. So you have your feature coming in here, which can easily kind of be translated into user story. So you have an addition feature. And in order to avoid blah, blah, in order to accomplish something, as a role, I want to be able to do something. That's your user story. And furthermore, you go into the scenario, or even multiple scenarios for that particular feature, and you start focusing in on the given and the when and the then. So given a specific scenario, given I have entered a 50 into the calculator for this particular one, and I entered 70 into the calculator, when I perform an action, in this case the add, I want a certain result to be on the screen. And for a unit, we want to focus on the latter part here. And for this presentation, I'm going to be focusing on the unit level of things. So this is the kind of language that I'm looking for to accomplish for my unit tests. So it's a given, when, then construct that I want. So as I mentioned, we want to be able to actually test the behaviors of our units. And basically what we will be doing then is not necessarily test state, but maybe more like interaction between the systems. You want to be sure that your unit interacts with other units in the correct manner. But you can also do simple state testing as well. And basically what I'm coming at is that everything is behavior happening to your system. Even though it looks like data, something is causing it. And what we'll hopefully gain from this, and hopefully get a sort of an insight into, is how you can actually get a better focus on decoupling your software from doing this kind of interaction based testing between the systems. In order for us to actually accomplish this, we need something called test doubles. We need implementations of the dependent systems that a unit is depending on that are basically kind of fake implementation. They're not real implementations and will not be ever used in production. So we need something that represents the dependencies that we have on our units. And there are different types of test doubles. You have something called fakes, and basically they are working implementations. They implement whatever interface that unit is depending on and has a working functionality internally, so it will not break or anything. But it usually takes shortcuts for typically infrastructure. So an example of that would be an in-memory database representation or similar. So that would be a fake. A stub is also interesting to actually have. It provides a canned answer. So basically when you're asking it, if you're performing an action on it, you can go and ask, what did that happen, and what happened with the call that actually was called upon it. It may also record information about the calls being made into it, so you can actually go and ask, well, what did it call you with? So if, for instance, if you have a subsystem that your unit is calling into, it might record the information passed along on the method calls, like parameters into the method calls, and just record them so you can go and ask what was being sent into it. The third thing that I find more and more useful are actually mocks. And these are sort of pre-programmed objects that we put expectations on. So we add expectations onto our mocks, and we can go and verify those expectations. And there are quite a few frameworks out there, TypeMock being one of them. And TypeMock also is really extensible when it comes to what it is capable of doing. And of the three of them there, it's probably the one that can actually do the most. But TypeMock is also really good for doing things like mocking out the .NET framework and things like that, something you cannot do with RhinoMox and MockU. But they all have sort of their own thing. So personally, I've used both TypeMock and MockU, and I use more TypeMock if I need to mock out things that are not mockable. If you have like an HTTP request, for instance, which is really hard even in ASP.NET MVC to get right when you do mock, TypeMock is a perfect fit for that, while I use MockU for pretty much anything that is more easily mockable. And what is common with these mock frameworks is that they can easily take over the role of the fakes and also the stubs, because they are so complex and advanced these days that you can actually start replacing your fakes and stubs with mocks instead. But coming into any kind of testing, either it's TDD or it's BDD, it's really important to remember that your code must be testable. Otherwise, you're going to have a nightmare. So let's say, for instance, you have code that actually takes on too much responsibility, and instead of being focused and have only one responsibility and might have 3 or 4 different responsibilities, that is code that is really, really hard to test, because all of a sudden you have to take into consideration all those responsibilities. So let's say you have a service, and that service takes on the responsibility of being a repository, but also takes on the responsibility of doing validation of things coming into the system, and maybe even do some mapping between some DTO and a domain object. Those 3 responsibilities, if that sits at the heart of that service, makes it really, really hard to actually test. And so what you want to do is decouple all these concerns and actually put them into separate things, and have the ability to actually mock them out to make your tests more focused. So basically, in short, what that means is go and look up the solid principles by our dear uncle in the US, Uncle Robert Martin, and apply those. They are good principles and will kind of get you there. So this doesn't change everything. It doesn't mean you have to change just about everything you've learned so far in software development. But your code will have to change if you're not already writing good decoupled code, of course, and writing code that is focusing on a single responsibility principle and the rest of the solid principles. Of course, if you are doing all these things, you're not going to change anything. So then you have already code that is really ready for writing tests. So, but the principles that I'm talking about, the solid principles, are really totally independent of testing. They just happen to align very well with testing. So applying those principles will just help you write better code, but also help you write testable code. So I would recommend doing that either way. So back to BDD. Do you need a framework for doing this? No, not necessarily. You can basically use, if you're used to doing NUnit or MS Test or any other like QUnit or something like that, you can basically go and use these frameworks. You don't have to change your framework, because it's all about a mindset. It's not about a framework. But there are frameworks out there that will help you get a better syntax and get you easier or make your code even more readable. And two of them are for the .NET space is the NBehave and something called MSpec. Personally, I've been using MSpec for the last couple of years, and I find that really nice. I'm not going to focus on frameworks today. I'm going to use MS Test later on. The most important thing is actually getting to a good structure. that you can use. And the structure will sort of give away everything. And it's the place, if you have a good structure, it's the place where you're going to point people to, and they can go and read things out very clearly. So the structure that I'm proposing today is basically, it's based upon what my experience with using MSpec is, and basically representing the given when-thems in a good, in my opinion, a good way. So what you're looking at here is basically a file structure where you have a project that you want to specify, and you add that into the name of the project and have a suffix of .specs. Within that, you're going to mimic the entire namespace structure that you already have in the project you're specifying. For every unit that you want to specify, you create a folder called for underscore and the name of the unit. Within this folder, you might have a given. Not necessarily, you don't necessarily have a given. That's only if you want to have a very specific given that you might want to have reuse, a certain context that you want to reuse across all the specifications that you're going to put here. And in the same folder, you're going to have your behaviors. And you're pretty much going to have a class per behavior. So when blah, 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 something is happening in your system. And within that, you're going to have all your then statements or it statements. It should. So a sample of this is from the Bifrost project I mentioned earlier, where we have something called Bifrost, and we have the specs for that. We have a namespace called commands, and we have a particular unit called command context, and it has a context of being a command context for a simple command with one tracked object. So it reads out pretty much what it's doing, and the behavior we're specifying here is when we are committing to it. So on the top level, if you want to move even further with behavior-driven development and do something more than only for the unit level, there are frameworks also for doing this. There's something called SpecFlow, and there's something called StoryQ, and also Qt for Nuke. SpecFlow and Qt for Nuke are probably the most closest you'll get to the Cucumber project, which is a Ruby project. And StoryQ is more programmatic, has a more programmatic approach to it. So I'm not going to go into depth with them, as this is more of a talk about how you do this on a unit level. So that means I have to write some code. So going for my Visual Studio, and I'll just move this. I have a web shop with sort of a domain that I've driven out. And I want to start on the cart. So I have an object called cart, and it basically holds a cart and some cart lines, and it has a total net price and a total gross price. And the cart line looks like this. It's basically a reference to a product ID, the product that we're adding to the cart, and the quantity of that product, how many items of that product you're adding, and the item's net price and gross price, and you have also the VAT rate for that product, for that particular product, and also a total net price and gross price. So this is state that I want to start off kind of specifying. So basically what I also have here is an empty project sitting over here with basically the Visual Studio Unit Test framework as a reference, but I've also pulled in something called fluent assertions, and that's going to help me make my tests more readable. So what I want to do is go in and already start mimicking that same structure that we have there. So the namespace is carts, and within carts I want to do specifications for the cart line. So I go in and add for cart line, and I want to add a certain specification to this. And notice already I really haven't done any logic on that cart line. It's just basic, simple DTO object sitting there with a bunch of properties and no sort of code actually representing anything. So that's what I want to change now. So I'm going to go in and start modeling my behaviors to this. So when setting the net price with that already specified, so this is what I want to do. And since I don't use MSpec or any other framework, I'm using just the MS Test one. I go and do this. So I add this as a test class. So what we're doing here is, because of something that we're doing, well, first of all, we are going to need a cart line. So we have a cart line like this, and it clearly says up here that we're going to specify the VAT. So let's already do that. VAT rate being, in Norway, it's pretty standard to have 25% VAT rate. So yeah, we are so screwed up here. So I have that, and what I want to do now is go and say, well, I'm going to set the item's net price to 1,000. And I want to have the expectations here. Well, I'm actually expecting this to calculate gross price according to that rate. That's what I'm expecting from this system. That means if I just pull in my fluent assertions, as I mentioned, to give a better read for my assertion, I can then go and do item gross price should be 1,250. And since I'm using MS Test, I need to do test initialize, and I also need to do test method for this. So that's my basics, and this is going to fail. So I also have something called test-driven installed, but you could basically go and do this. So run tests in current context, but that's of course not going to work because it's demo time, so I'm going to just do test-driven.net instead. And what that does is pull up this. So test when setting net price with VAT, it should calculate gross price according to that rate, failed. Expected 1,250, but found 0. Okay, but that makes sense. We haven't really done anything yet, so let's go and do something to that. So basically what I can go and do now is say, well, the gross price is the same as item net price plus item net price multiplied by that rate divided by 100. That should be the correct result for that. And we can verify that by running our test. And it passed. So yeah. So let's move forward a little bit more and start adding more things to this cart line. So I've already added that. And let's say I want to set the quantity to 1. And I do the same thing here. I do a test class, include that. And I do a test initialize, which is going to be my because of, and I'm going to do my expectations. So I'm expecting this to have total net price be the same as item net price. When I'm only setting 1, I'm expecting the same total net price to be the same as the item's net price. So, and I can add a second one. I can go and say, well, it should have this total gross price be same as items gross price. So that's our basics, right? And we start doing our setup here. So we have a cart line with a certain, well, it has a certain VAT rate, 25. It also has a certain net price, which could be 1,000, like so. And because we are setting the quantity to 1, we are expecting this to actually yield the same result. So cart line's total net price should be, and it should be the same as the cart line's item net price, which is basically not. So we can go and fix that code over here. So our total net price would be, well, and that will of course not fail because it's the same. So it passed. And we can of course go and do the same thing for the total gross price. And see that it failed. And go and fix it. And of course, you're already seeing that this is a very naive implementation. But I'm not jumping to conclusions just yet. I'm taking this kind of slowly, moving slowly into it. So what happens if we want to set the quantity to 2? To 2. And of course, again, we have to do this. And we do a test initialize. Of course, this might actually look a little bit painful, but I can rest assure you, if you want to try out things like MSpec, it's a lot less painful because it's built into the sort of DSL that they provide. So we have our cart line still. And it's a cart line of item net price of 1,000 and I had a VAT rate of 25, and that's it. So because of we're setting the quantity to 2, it should actually yield the correct result. It should have total net price same as item net price multiplied by 2. Cart line and the item total net price should be, and then we can do cart line dot item net price multiplied by 2. So this is what we're expecting. And of course, it will not be because we didn't do that implementation. So basically what we can go and do then is, well, fix it and actually do multiply it by quantity. And that should not fail anymore. Yes, we have a passing specification for that. I think you're getting the picture, so I'm not gonna do that for the gross price. I can, however, do the implementation, which of course is going to be a quantity like that. So that's your cart line, and now we have a set of specifications sitting here. And we can actually go in here and actually run them all. And we have 4 past specifications, and that's it. So what if we move this up one notch and go into something like the carts, and we want to add a certain behavior, because what we basically did now is more like state testing on that particular object. We change some state, we model it as if we do a behavior on it, and we see what kind of state comes out of it. So what if we go and do something like more advanced stuff, like you have a cart and you want to add a cart line to this. So we want to have this method. And of course, it's going to be throwing in our implemented exception. That's a good test first approach. We're not going to put any logic into that just yet. So we go here and we again create a folder for the unit that we're going to test, which is the cart for the cart. Here are the specifications for the cart. And what we're going to do is add specifications for this. That's going to say, when adding one cart line. So what happens then? So now it would be a good time to actually go and introduce a given. So let's go and say given an empty cart. Something that we can reuse. So this is going to be something that we're inheriting, right? So, and it reads out kind of nice as well. When adding one cart line, given an empty cart. Pretty much English, right? So an empty cart would be basically something like this. That's an empty cart. There's nothing in it, basically. So when adding one cart line, so because of we're doing something to it, and of course I have to do this again. So because of we're adding a line to this cart. So we have the cart, which is for the moment a private variable here, but we can make it protected so I can actually start using it. So going back to our specification here, so our cart has this method called add cart line. So adding a cart line, we can just do this. And we can say it should have one cart line. So the cart should now have a count of 1. But of course, we have no implementation yet. So this is going to crash, not implemented exception. So we go to our cart and we can start actually just adding that line. So add cart line, and that specification should be good to go. So, but we might want to sort of juice this up a little bit and get more advanced, because the cart obviously looks like it's going to have something happen to these values whenever I add something to the lines. So we might want to actually go and do something a bit to that. So maybe we want to rename this. So maybe we want to have it something like, when adding one cart line with price set. So we're more specific. So what we're going to actually do is we're going to do item net price, which is still going to be 1,000, and we'll have the VAT rate of 25, and that should be it. We're also expecting then to actually have the right values on it. So it should have the total, and of course the quantity I forgot, which is 1. It should have total net price set to items total net price. So basically our cart should have its total net price should be the same as the cart line. And now that I see this, I want to really have that cart line actually sit up here. So I don't want to have that just in here. I want to actually move that across to this place. So I want to have it to be the same as the cart line's net price, the total net price. And it's clearly not. So what we can then do is go and fix that code. And we could do that either every time you're adding something, or we could do it on the fly when reading this value. Personally, I think I'm actually going to make these private and actually do the update here. So what I'm going to do now is total net price equals, and I'm going to do the lines, and I'm going to need link for this. So I'm going to need a system link, and I'm going to do a sum of the total net price and put into that variable. And it should yield a passed specification. So I think I'm kind of getting to the more interesting parts now. So I'm not going to do more on this object even. So let's move up to something that requires us to have fake implementations or mocks even. So let's go and see the cart repository. I have yet not implemented this. So I can go and actually add a class called cart repository that will basically implement the cart repository. And it will be implement this interface implicitly. So this is basically what we need. We need a behavior for actually getting a cart for a current user. So how do I know about a current user? That's something that we need to resolve. So if I look at the structure here, I have something called infrastructure. So I've created a small little infrastructure with something called a user service. And I think that's a good candidate for actually doing this. It has a get current user. So I have something that can give me the current user. I also have something here for accessing entities in some kind of data context. So I have that, and it has the ability to do queries and whatnot. So that sits there. So that gives me a general idea of what I can do here. But I'm going to go back and actually start writing the specifications for this. So for our cart repository, when getting for current user with an existing cart. And basically what we're looking at is it should do something. So what should it do? And this is sort of a pickle you end up with. And this is sort of where you might want to say that instead of saying you're doing test first only, you're basically sort of testing at the same time as you write the implementation, because you might not even know exactly how to pull this together, and there might be services already implemented that you want to take and utilize. So basically what you can do is start looking at, okay, how do I actually do this? So I already showed you that I have something called a user service, so that would be a good time to pull in that as a dependency. So I need a user service to actually be able to do this. And I also had a sort of a data context for dealing with data coming from a data source. So, and it was called entity context. And I'm working with an object called cart. So that will be a good fit. So that's my sort of generic repository for dealing with data. So that's my cart entity context. And of course I want to store this since I want to use it. So I do user service, and I store that as a user service like this. And I have the entity context coming in there. And I can do basically like this. And I can store these so I can use them in my implementation. So the cart entity context, and like so. So now I basically made my contract for this repository, and that is what I need to actually go and work with. So what I'm going to do now is basically say that I'm going to expect some kind of interaction. I'm going to expect it to interact with the user service. So it should ask the user service for the current user. This is an expectation that I'm expecting from this system. I'm also expecting it to ask for the current cart. Through its entity context. So putting in my boilerplate stuff here for MS test and my test method, like so. And because of that, let's see here, because I'm actually getting the current user's cart, so we need the cart service, the cart repository. And I want to have that in a given. So given a cart repository, like so. So cart repository and that needs to be initialized. So how do we do that? Well, if we do it in a static manner like this, we can actually just initialize it directly here. And it has a couple of dependencies. So we have the user service, and we also have the cart entity context thing coming in there. And these are things that we don't have. We don't have implementations that we can just give to it. And this is where typically a mock framework would come in and actually provide you a good way of doing this. But I'm going to actually just create this without doing any framework at all. So what I'm going to do is create a fake kind of a fake user service sitting here, which is going to implement the user service. And of course, I need a reference to the infrastructure to be able to actually do that. So I do this and such. And now I actually need to implement that interface. So it returns the current user. Well, we can do that. We can actually just basically have our current user kind of sitting here. And just new it up like this and even give it a name. It's a test user, or even better, it's a specification user. So we just return that. That's our current user, and that's a good enough implementation for our specifications to actually have this. So we go back to our construction of the repository here, and we can give it that fake one, fake user service. So what about the next one, the entity context cart? Okay, so we can do the same thing with that. We go in here and we add a class, and we do our fake cart entity context, like so, and basically say entity context of cart, like so, and we implement that interface. We basically will not be needing most of this right now, so I'm just going to do a little thing here where I actually have the ability to set to actually be able to set the entities manually in the test, so I can set up my expectations correctly. So I have that now, and what I want to do is I want to keep that around. I want to have that instance of the fake cart entity context hanging around here, so I can start doing things to it. So your cart entity context, I add that there, and now I have my cart repository set up for my specifications. So basically, if I go to my class here, I want to inherit from this. I now have my cart repository, and it has a get for current user. So I want to have the cart. So that's our result, like that. And now I can go and say, well, I'm expecting it to call the user service for its current user. So let's go and actually say we store that state. So we store a Boolean saying get current user called. Default is false. And we just set it to true. So basically what we're saying is that we want to just check the state of that. And that brings me back to this because I remember doing something wrong. I actually need to keep that around as well. So the instance of the fake user service also needs to be kept around. So the user service is this. So I'm able to actually check the state of that. So going back to the specification now, I can actually go and check if that will be called. So I can go and say, well, my user service get current user called should be true. Test class. Sorry. So, and of course that's not implemented yet. So what we can now go do is, well, we can return a null because we're not specifying that yet. So we can go and get the user. So current user being the user service dot get current user. And let's see if that's okay. And it passed. So we've just specified the interaction between these two systems for this particular method. So it should also go and ask the cart through the entity context. And of course, again, we can go and do the same thing. We can go and just implement this. But the best way to actually do this is probably to pre-populate this to see if we get the cart object that we're expecting back. So we're basically having a cart object, and if we look at the cart object, it has nothing about user in it. So we should probably go and add something like a something representing it. And username could be it, or a GUID would probably be better, but in the interest of time, I'm just going to do this. So this is the thing that's going to distinguish it from between the users, right? So what we want to do then is actually at this level, we want to have the entity context for this object, or the data context for this cart, pre-populated with some data. So basically what we can do is go and say the cart entity context, and the query, the entities, will be this array of objects. So it's going to be a cart, and the username is going to be the same as in the current users in this place. Sorry, in the fake user service. So I want to actually, for this particular scenario, I actually want to make that public, so it's available for me to use outside as well. So now I can actually go and say, well, I have this fake user service, and it has this current user name, and I just want to have that cart sit there. So what we can actually go now and do is put up some expectations for this. So if we store that cart, so this is our expected cart, I can do expected like so, and I can also do ask queryable of cart like so. I actually don't need to specify that, so it's actually a queryable object we're putting in there. So basically what I'm expecting now is the expected should be same as the result, which is, it's not going to be. It's actually null, and we're not returning anything yet. So now we can start testing the entity context. So what we basically want to do is use link here and say on the entities where the cart's user is the same as the current user's username, right? So we want to return that like so. And it passed. So a little recap of what just happened. We have a repository instance sitting here. It's initialized with 2 fake representations of the dependencies that particular repository was depending on. The user service and a entity context of the type cart. And these are fakes that I can control to some extent from my specification. Going back to the specification, I'm basically just calling into this to the repository and getting just calling that functionality, and I'm expecting some result. So expecting for this particular scenario, I'm expecting that the current user actually is called on that service. So I'm sort of saying that I'm expecting a certain interaction between these systems. And I'm also doing this for the entity context, but this time I'm actually handing it the data that I know it should be able to filter out and return what I'm expecting it to return. Okay. So I see that I'm actually over time. So let's conclude the code bits and go further. One thing that you might see is, well, one of the things that I'm using is something called test-driven.net. It's a tool that enables you to actually run the tests a lot faster than the test runner that is in Visual Studio. But the built-in test runner in Visual Studio will give you the kind of red-green lights for the tests and actually give you a visual feedback. Test-driven only gives you a textual feedback at the very bottom. And if you're sort of interested in that kind of feedback loop, I find that really, really good. Another alternative to getting a great feedback loop is if you have kind of low compile times of your projects, is something called Mighty Moose or nCrunch. These tools will give you sort of a continuous test run. Whenever you save a file, it will automatically figure out what needs to be compiled and what tests are affected by the change you just did, and run accordingly and give you the feedback as fast as possible. Both of these tools are implemented into Visual Studio. So I have some recommended reading. There's the Dan North's blog, of course, and the Cucumber book. Also a book called the RSpec book, which I found really, really good. Even though it's for Ruby, it's a good way to actually get into the mindset of BDD. It explains the relationship between a unit and the acceptance. So the kind of low-level unit specification that I've been doing today, and typically the relationship with Cucumber or SpecFlow in the .NET space, or Cuke for Nuke, for that matter. So that brings me over to the Q&A. So let's actually see if there are any questions?
Einar, I have a question from Patrick. No. What is the stance on code coverage and edge case testing? How much is enough?
That's really a hard hard question to actually answer. What is good enough? I actually, when you're, it's probably easier to come to the conclusion of what is good enough when you're doing behavior-driven rather than doing test-driven, because you're basically modeling the behavior. So unless the user is specifying something very specific, chances are you don't need to go all that far. So I tend to say it's actually it's sort of the 80-20 rule on that. 80% is good enough for that. Of course, everyone's free to drop me an email if you don't want to ask questions now, or I forgot to mention at the very beginning of this, but this session is being recorded, so you can actually go back and look at it. And if you have any questions, please feel free to do it offline. Drop me an email at any time. And I'm also on Twitter, so @INARI. Please also start a conversation, dialogue with me there. No problem.
We also have a question. What is the role of a tester in BDD?
Tester. A regular tester. Well, to be honest, I haven't actually worked with regular testers in the BDD sense. They tend to go in on a user story level and more with the acceptance criteria of a user story and actually drive from that. But what you can get with software like SpecFlow or Cucumber is you basically could have business people lay out the tests for you or the specifications for you, and that would be sort of the heart rate of your application, and you could use that for planning and actually the progress of your project as well. So it fits very well with agile methodologies and stuff like that. But when it comes to regular testers, I assume you're thinking more like the integration test or acceptance test of your software before it's actually put into production. Well, I think you still need to do that on a different level. You might be able to use the Gherkin language to actually specify this, but chances are you might be better off just using the user stories and criteria there. One more thing. Go and create software with less bugs. Really important.